Okay, so interphase, we have the cell. Okay, just like the cell we drew the other day. All right, interphase is just the original cell. Okay, interphase has the nucleus, the nucleolus. It has the little vacuoles. It has the endoplasmic reticulum. When we talk about interphase, it's a regular cell. Okay, in interphase we have the regular cell. The cell spends most of its life in interphase. Just spends its time existing. A skin cell out on your skin, a brain cell, heart cell, lung cell, doesn't matter. Interphase is where it exists most of the time. If you had a test question that says which phase of mitosis are most of your cells at, they're at interphase. Okay, they're at interphase. Now, so that's step one. There we go, interphase. Now, what happens is, as the cell decides that, once again, it's really incredible, and I know I say this, and you're going to be like, oh, Mr. Anderson, don't say that again, but it's really incredible that it's not just two cells colliding, and two cells made this Big Bang theory here, because the cell has an incredible instinct that we can't simulate, that we don't know why, but it has this incredible instinct to know that it's got to divide, okay? So, in prophase, the second step of mitosis, all right, in prophase, it's kind of interesting because now in prophase, you can't see it really good in the stage here, but the wall of the nucleus, okay, because where's the genetic material? The genetic material is in the nucleus, okay, in the nucleolus. Remember, the nucleus has the DNA, the nucleolus has the RNA. So what begins to happen is this nuclear membrane here begins to break down so the DNA can come out of the nucleus. Okay? So interphase is the existing cell. In prophase, the nuclear material, okay, the nuclear membrane begins to break down. Okay? Nuclear membrane. We're going to start letting this DNA out of the cell. Okay? Now let's move on to metaphase. All right. So in interphase, you've got the cell that's existing there, and in prophase, the nuclear membrane. Okay. So what's happening in prophase? Okay. The nuclear membrane. All right. The nuclear membrane dissolves. Wow. Wow, isn't that incredible? The nuclear membrane begins to break down, get really small, begins to dissolve. So, here's the thing. How do these cells know that? And it's amazing because one cell becomes two cells become four, and they continually divide. As a matter of fact, your skin cells form these cells and grow and die to the point to where every 20 days you develop a new line of skin cells on your entire body. Wow! But it's a few at a time. Now, what happens is you don't take a bath. Okay, the old skin cells that die, they begin to deteriorate and rot and smell, and that's called body odor. Okay, so when we take a bath, we wash off the old skin cells, and we continually make new skin cells. Your body's constantly doing that. Okay, that's why we have a certain amount of protein within our diet, because the actual cells are made up of protein. Isn't that amazing? Okay. So metaphase is kind of interesting. Okay, metaphase is where things begin to come together. So in metaphase, all right, metaphase, we form what's called spindle fibers. Now, once again, you have this. You have this. It's incredible. We have a deal. We have something called centrioles in our cell. A centriole is a little packet of spindle fibers here, and that's in every cell. It's called centriole. And so what happens is, whenever it reaches this point, okay, then this breaks loose. And then all of these spindle fibers form this nice magnetic field around the cell. Isn't that amazing? And there's one line that's down the middle. Okay, there's one part that's down the middle. All right, there's one part that's down the middle. So what happens is in metaphase it starts out, and I wanted to. We're not gonna cover it in a lot of detail. But in prophase, these centrioles begin to break out the spindle fiber. Some books will tell you that spindle fibers, begin in prophase, and high school books kind of simplify it. A lot of new research in the college, and so I'm not going to ask you exactly all these different things. I just want you to know the general idea. So, but in prophase, and we're not going to ask you this part on the test, but the centrioles begin to come out. That's why some people talk about spindle fibers, and sometimes there's prophase 1 and 2. We'll talk about that in a little bit. But by the time we have metaphase, we have this nice magnetic field. Okay, we have this nice magnetic field. And so everything begins to line up in the middle. So now we have all this material, all this DNA that's beginning to line up in the middle of the cell. Isn't that amazing? Okay, it's beginning to. So metaphase, we have spindle fibers. Okay, metaphase, we have spindle fibers. Now, got ahead of myself a little bit. Let's make sure we have this. Metaphase is spindle fibers. Okay, anaphase. Okay, anaphase, all the genetic material, the DNA and the RNA. Okay, all the genetic material line up in the center of the cell. Okay, now once again, it's kind of interesting. It's kind of interesting because I've taught high school biology for years as well. It's kind of interesting because even textbooks, there's even a little bit of question on this, and I'm not going to go into a lot of detail of the research, but it's interesting how for years we kind of lump things in. There's really a lot more going on there than we realize. Okay, so in anaphase, this is where everything's lined up in the middle. Okay, isn't that cool? So now everything is lined up directly in the middle. What are we going to do? What are we going to do? Well, we're actually going to split the cell in half. We're going to split the cell in half. So we've got one side of the cell, okay, and then we're going to do something called transcription, where we make the other side of the cell. That's why we have a little bit of contradiction in terms of where all this stuff happens. Okay, so in anaphase, okay, everything lines up to the middle. Now, we're kind of talking about in between metaphase and anaphase, all these different things happen. But for you, for your test, what I want you to remember is metaphase, the spindle fibers come out. Okay, it forms this magnetic field. Okay, and I want you to remember that in anaphase, all the genetic material line up in the center of the cell. Now, it's kind of a crossover. Metaphase begins to make the spindle fibers, but I want you to kind of know this in this way. So what happens is now that we have this big section here, now it's going to start to pull and separate. It's going to start to separate the nucleus and all the genetic material in half. Okay, so in later anaphase, I want to define. Let's define telophase, and then I'll draw this. Okay, in telophase, the cell splits into two cells. Okay? All right? So we begin to get this. Let me draw this so we can see this. Okay? Once again, this is mitosis. Okay? This is mitosis. Let me get my little cleaner here. Okay, so this is mitosis. All right? So the cell comes in. The cell starts out in interphase. Interpro, meta, and tele. So the cell starts out in interphase. It sets there, okay? And then it goes to prophase, where the nuclear membrane begins to get real thin, allows the nuclear material to go out. Metaphase, we have the spindle fibers. Anaphase, everything lines up in the middle. Then in telophase, the cell begins to split. Okay, the cell begins to split. So what we have is this. We have this to where we have the cell actually begins to start to split off to where we actually have two different cells. So we have the nucleus, okay, and as the cell begins to split in telophase, then those cells go down and make 2 new cells. Now what stage are we in? Now we're back to interphase. So telophase, cell splits into 2 cells. Okay, now, sounds easy, looks easy, you're like, okay, well, that all makes sense. Let's talk about, there's a lot more going on here than just that, okay? So how did we get 2 cells when we split this one in half? Okay, how did we get 2 cells when we split this one in half? Well, we did something called transcription. That's why we had to cover DNA first before we covered mitosis.